Sir, you can share the screen.
Yes, okay.
Okay, thank you, sir.
Is it visible, sir?
Yes, sir. Is it visible? Okay,
Okay.
okay, okay, sir.
Yes. So see, we have seen till the point of DCS and PLC. So now we will try to solve some programs or try to see the softwares, how it look like. Now we can program the PLC using ladder logics, and we can also draw some graphics on SCADA screen and try to give the tags of this graphics to the PLC and check the our screen is going, our programming is going good or not. Okay. So before that, we first need to understand what is SCADA is. So at the starting of this session, also as I have said that SCADA is what? It's a supervisory control and data acquisition software. Correct. Supervisory control means it is having a control of all the parameters in the which is connected to the PLC. And data acquisitions means what? It always acquires the data from the devices and it will store inside their memory. Okay, so what it provides a dynamic process graphics. Dynamic process means, let's say you have multiple bottles, okay, moving on a conveyor belt. Okay, that conveyor belt is showing the moving of these bottles on a conveyor belt. Okay, if somewhere there is a fault, then if the conveyor is stopped at certain point, then this graphics will also stop at that point, and it will gives you the graphical faulty representations what is going on in the field. It will show the representation. It's just like a camera, but it is not a like camera is a real time, but in graphics we are designing our own uh, picture. Okay, so that is why this is always a dynamic process graphics representation, and it is also giving us a real time and historical data of, like, say, temperature, pressure, flow, or speed. Okay, what means in kind of trend format with respect to time. With respect to time, how my temperature is going on. So this is a trending data. It will always show in a graphics. Correct. Then alarms. If any alarm generated in the system, then it will give me the kind of alarm kind of things. It will announce. It will start annunciator. Then it will give me the kind of which actions you have to perform for certain alarms. If my temperature is goes beyond certain limit, then you need to take care this action. Okay, and that action it will tell by the SCADA screen. Okay, then security management. Okay, then database connector, whatever the things we are seeing here, all these things we can see on a SCADA software. Okay, so what is the basic difference of PLC and SCADA? That is the most important question, because PLC, as we have seen here right now, PLC is what? PLC is a hardware. Okay, and SCADA is what? It is a software. Okay, this is the best, means most important difference between PLC and SCADA. PLC is a hardware, SCADA is a software. Correct. Just I have shown here the device of PLC which I'm having. Okay, so this is the solid state device. Correct. It is just a software. It's all in a PC that we will also see using some programs. Correct. And we can connect multiple input to this, and we can also connect multiple input, but we cannot control without this PLC because A software is a software means, let's say if you have a software in your PC and your device is here like motor, okay, and that motor you have to control using this SCADA. And is it possible? Answer is no, because you don't have a interfacing medium. Because how this motor is communicate with this SCADA? You require a PLC to communicate between SCADA and device. Correct. So SCADA is only doing control through the PLC, and it is also showing you the graphics, means speed of motor, then what is the level of the tank, whatever it may be, it will show in a pictorial format. But you cannot control directly the motor without a PLC, because PLC is having input and output slot here, correct? And that output slot will allow to communicate this hardwired motor, correct? So this is the basic things we required for SCADA. Means even if you have a SCADA, you cannot control without PLC. Are you getting? So because this is the hardware and this is the software. Okay, and so fine. So this is the overview display and detailed display of SCADA. I'm just giving you the brief of the SCADA, how it look likes, because in few moments we will try to solve one problem using PLC software, and we will try to indicate what we are doing on a screen or in a field, how it is representing, correct? Fine. So this is a detailed display. We just like if you have a flow indicator. So this flow indicator having multiple parameters like set point, process variable, set variable, manual control, how the control wall is opening to maintain the flow, then it is automatic or control mode. So all these parameters it show on this faceplate. Okay, so this is the detailed display. Okay, but in overview display, you only get certain things, means like process variable only. Process variable means what is the pressure, what is the temperature, what is the flow. Only these things you are getting for various parameters. This is only one parameter, but overall information. But it is various parameters, but only one information of the parameter. Correct. So these are like faceplates we have in a SCADAs, and these are the some screens you might see in industry, that if you have to check the trends mean how the data is behaving. Okay, temperature is behaving, so that temperature's nature with respect to time we can monitor on a trend data. This is the trends. Okay, and these are other graphics, depends on the applications. We can monitor other parameters as well here. Means what is the pressure, temperature, what is the set point. You can see here set value, process value. All these values or temperature, pressure, flow, you can monitor on a screen itself. You don't need to go and check the programs, what is there, the value of this. You can directly see on a screen. Correct? So this is how you can reduce the human efforts here using SCADA graphics. We will build one SCADA in few moments, and we will try to indicate our parameters using PLC programming. It is very easy thing. Supervisory control line. These are the some company manufactures SCADA, means InTouch, Wonderware, which we will going to demonstrate in few moments. Then Siemens company produce this WinCC SCADA. Then National Instruments means NI LabVIEW, what you can say, that produce the SCADA of Lookout, GE General Electric, that Simplicity SCADA, and Allen Bradley produce RSView 32, which is right now absolute, since it is not used in industry. Currently they use factory talk automation, the name of SCADA of Allen Bradley. They use factory talk automation, not RSQ. And if you knows the thing in automation, so these are the areas which you can focus for jobs options. Okay, so if you know the PLC, TCS, whatever the things in your domain, means what are the controlling part, programming part, you knows, then you can go for the automation jobs. But if you also understand the how the sensors work, how transducers work, then concept of sensors, transducers, then P and ID drawings. These are the some things which we discussed in instrumentation background. So if you know these things as well, then you can follow for the EPC companies. There are two ways to go into your career. One is automation and then second one is the EPC. Fine. So if you understand the PLC and DCS, then you go for automation side. Otherwise, you go for the EPC side. So this is how it goes in industry. Fine. So just now I have just completed the introduction of PLC, DCS, and SCADA. Correct. So still we have not discussed the software part, how it looked like and how to do the programs in the PLC. We have seen only hardware and architecture. We have not seen the how to do the programs in ladder logics. So we'll try to see that as well. Let me start the PLC program here. So see, this is just like a ladder like options. You can see here. This is a ladder like option, correct? So that is why it is called as a ladder logics. Now, first time, what we will do, we'll tap on this PLC program symbol. Is the name of software is RS Logics 500. Okay. And now I will take one, I will select the processor, whatever the processor I am having with me, that processor name I have to choose here. So I will choose, is it okay? Means everyone got what I'm saying till this point. If anyone having doubts, then they are free to ask in chat box. Okay, I will try to give answer for whatever the issue you are facing. Okay, so right now we are going for the programming part, how they do the programs in the industry. So first go and select the processor type. So processor type is I'm having 1200 series C, and later it will gives you the platform of screen. This is how it look like, this screen. Okay, and in this screen on the left hand side you can see there is a controller option, and inside controller options you have option of IO configuration, how many IOs you have connected to the PLC, what are the properties of controller, what are the processor status of the controller. All these informations, just like a setting, basic setting, we need to give, we need to do here. Okay, and then there are the ladders. These are the ladders. If you take one ladder and second, third, or see, these are the ladders coming. If you take this, fine. Then this is the program files. Okay, inside this program files you can also take another ladder as well. It's ladder 2. If you have to do the more program, then it will take as a ladder 3, ladder 4. Correct? How many ladders at a time in the one ladder? So 9999. These many ladders we can use inside one ladder. Means one ladder. If you have to increase to another one, then you can just click right one, take new, and insert another ladder. And that in that ladder as well, you can use 9999 ladders. Okay, it's just like your microprocessor, just correlated with your basic concept of microprocessor. Means in microprocessor, what you do, means if you have to jump to another logic. Okay, so at that time you use the jump instruction, jump to address of that and return back to address where you have left. Okay, the same thing is here. If you have to repeat one thing again and again, then that logics can be made inside one adder logic. And whenever you require that logic, you just jump to certain ladder, do the task, return back to first ladder where you have left. Okay, so this is how it works, these ladders. Then below you can see, there are data files. Okay, this is okay. And data files means which inputs you are dealing with. Means data types, I know, integer data type, float, whatever that thing you all considered in these things. Means if you have output, what is the address of that output? There are multiple outputs connected to the PLC. We have seen in architecture, but which number of output, which number of input you have to choose. So that output and input can be choose from here. Let's say if you double click on this, you have 16 number of outputs. So out of this, I require this one. So I will try to give the address of that output to certain output parameters. So let's say I am having one input here. Okay, I will try to delete these rungs. These are called as rungs. Okay, this is first rung. I'm taking one input here and one output here. Okay, one input and one output. Let's say input, if I double click on input, it will give me the address of that input. I just try, drag and drop on the input. This is NO context, normally open context. If I give a supply, or if I give an input of this address as a 1, then it will try to pass the signal from here to here. Okay, I will properly tell after certain time. You will be understand all this. Okay, so this is the output. Okay, now what happens? I did the program right now. If the, let's say this is my push button. Okay, this is my push button. This is my push button. And this is my motor. Okay, this is my motor. Okay, so the problem statement is that when I press the push button, motor should start. Is it okay? So when I press the push button, motor should start. Okay, so let us say I have designed the logic. I will.
Tushar, sorry to interrupt you. Can you make full screen?
Yes. Okay. Now it is clear. So, so this is my push button and this is the motor. Now, first thing I have to evaluate, is it verify the project, is it okay or not? So I will press the button verify project first, and it will give me no errors here. If I did any mistake here, then if I do the verify project, it will show me the errors. It will say the rung has no instruction. So see, you can say error EEE. This comes here. I will delete this one. Okay, and again verify. Will not showing any errors. Verified has complete, no errors found. You can see on the left bottom side. So now, so my program is ready. Now what I have to do? I have to download. Same thing. That's what you might do in a Arduino. Same thing. We have to download it in a controller PLC. So for that, there are buttons of there are various functions here. You can see here, out of which we required a download one, which is in a communications. Okay, that communication can be done using this download. Here there is a download button. But before that, we have to choose our PLC. We have not choose our PLC. For that, we require a property of controller. Okay, then you have to choose who active, which processor is active right now in a PLC. In a okay, there is no PLC inside our this network. Okay, on this network there is no PLC till now. So we have to prepare one PLC for that. So what we will do, we'll take one project, like say we have to save first. We have to save this one. We will save this. We'll save verifier can save. Okay, and later we will try to open that the same project which we are dealing with. Open, and we have to give a station name, because on one station you have multiple PLCs. Means 31 PLC you can connect on one station. So out of which I am giving the address of 2 for my PLC. Okay, so it is started my PLC. So now I can download my program on that PLC. So click on controller properties. Let's say who active. Now you can see there is a controller PLC is there. So you can choose that thing, press OK, apply, and press OK. So now I am able to download a program inside that PLC. So click on communication and press download. So it will download the program. And do you want to go online? So this means what? If a program is downloaded inside the PC and it is asking me that you have to check the logic which you have made. Okay, so I have to check the logic. So press yes. So if you press yes, then it is started running. It is in running mode. Okay, but still it is in program, remote program. You have to run it. So after pressing run, it will start run, and automatically you can see here there are 2 green lines comes here. These 2 green lines means what? You are getting a power supply to your logic. Okay, let's say this is a line voltage, it's phase. Okay, and it is trying to go and getting ground. Okay, this terminology you can assume. So it is getting a supply voltage from here and it is trying to go for the ground. Okay, but what happens that here the input is not turned to 1. This push button is not yet 1. I have not pressed the push button here on my side. If I press the push button, then what happens? The status of this input will change to 1 and it will pass the supply and turn on the motor output of which is at the location of 0. Correct? So how it can be happen? So one thing can be done using using hardware. So if you have hardware connected to the PLC, tap on that push button just like your motor. Okay, you just press on that green push button and it will send this green supply voltage to this motor. It is not like that. Assume only the supply of line voltage. Basically it will just give a 1 input. It will just turn on this output 1. Okay, you can see here the status of this output bit, 0th number is now what? Is 0 right now. Now when you turn on this button, right now I am not having any kind of push button with me. So what I will do, I will make it 1 using force. Force input I also tell during the architecture of PLC or okay. So I will right click on this and force on. Force on will makes what? This motor will turn to 1. Okay, this address will turn to 1, and whatever the connections connected to this address on a PLC will be on. Are you getting? So I will making it 1. Toggle force 1. So now you can see this bit goes to 1. Okay. So this is how you can make your motor 1. Now what happens if I release this button? So this is I'm releasing. I have released the motor. It is come back to your own status motor. But in industry or in let's say in your home appliances only, what you do during turning on your pump or motor, you just press the green button for starting, correct? And to stop, you press red button. Is it or not? So we will do the same kind of logic here. Okay. So we will press the push button. I just pressed it and released it. When I released, motor status becomes 0 only again. Correct? When I pressed, motor status goes to 1. Just we have seen. Now what we will do, we will try to replicate the logic which we seen in our daily pump applications, motor applications. We'll consider that we have 2 push buttons. One is green and one is red. Okay. So to make changes in the program, what we will do, we will turn off the running mode. If the program is in running condition, we cannot download. So that is why we have to go offline. So for offline, press on here and then go offline. After going offline, we will take a one contact, that is NC contact. Okay. So this NC contact, what it will do, it will act as a normally closed switch. So I will take the address of this I:0/1 and it is again a push button. I will write it like a stop push button. Is it okay? And this is like a start push button. Okay. And I will latch the status of motor. Okay. So we are in a first stage of programming, so I will make it simple. Okay, I will not okay, fine, we'll try to understand this also. Okay, so I will taking a rung branch. This is the parallel branch. This parallel branch, what it does, it will try to turn on the all the things at means parallel. Okay, and I'm taking here the address of the same motor itself. Okay, what happens first time when the motor turns on from this start push button? Okay, so it will, what happens, it will turns to 1, correct? So the same status is replicated here as well, because I'm taking the address of the motor, but I'm considering it as an input condition, correct? So it is taking the address of same motor, but it is taking as an input condition. So it will consider 1 only, even after releasing of push button status, correct? It will remain 1. It will remain 1, and the path will not break. Even after I release the push button, the control will remain start through this path. Means motor will remain on. Okay, control will remain on. Let me show you this thing. I'm just not taking the stop push button right now. Just I have to replicate this thing. Just save this and download it. Okay. I'm going to running mode. Just I'm toggle and release. After release, if I pressed and released, even if I release the push button, then also motor is on. Means our first logic is fulfilled. Means turning on motor using start push button. Correct. How it happens? Means just I said that when I press the push button, it turns to 1. Okay. And it send back the signal to the this input address, and it comes to be it changes to the 1, and all the supply is started flowing through this path, and it remains 1 for a long time. Are you getting? So even if I release this push button, it is started motor. So these are like called as a auxiliary contact inside the motors in field. There is auxiliary contact which make the motor on, or if you started, it is like latch thing. Okay. But now we have started the motor, but we don't have any control to turn off the motor. So to turn off, we need to break the contact. This contact should be break. Okay. So if this contact break, then it will send a 0. Just send 0, replicate here, and it will not turn on this thing, and motor will shut down. Correct? Motor will shut down. Are you getting? So to break the contact, this contact, we use a interlock of NC. NC always called as an interlock. Okay. So if you use NC contact here, then what happens? If I press this input, okay, this stop button, if I press, this will open. Right now it is closed, but whenever you stop, you have to stop the motor. What happens? If I press the stop push button, what happens? It will open like this. And if it is open, how can the supply pass to the motor? It will not pass. And that's why motor will stop. So let us do this by program. Let me go offline first. Offline. This is /1. Then stop push button. Let me download it again. Okay, so now it is downloaded, and now we can check. First, I am toggle this bit, means I'm pressing the push button now. Okay, toggle and release, press and release. What happens? Even the supply is not going from this way. It finds the another way to go supply and turn on this bit O:0/0 to 1. So if this bit is 1, means what? This bit 1 is means what? Motor is on the field. Correct. Field is started, motor is started running. Okay. But now you have to turn off the motor. So for that, you have to turn on this push button. So as soon as you press, this push button, supply will lose from here only. Here, just I have pressed and release. Since this is the push button, I have to press and release. The release means the normal condition of this button is NC, no change. But if I press, it will open just like this. It will open. Are you getting? So this is how we can stop the motor to run. So this is the simple logic I have tried to explain. Start push button and stop push button. There are many other logics as well using motors. So same logics you can do using latch and unlatch. Means uh, this logics. Okay, this instructions. Okay, fine. There are many types of the logics: latch type, unlatch type, timer, counter. Whatever the things you have to manage, you can do it with. Let's take an example of timer one. Okay, I'm taking one example of timer, and my uh, problem statement is what? When I press the button, the start push button, it should take a time of 10 seconds, and then it will start the motor. Now, instead of this motor, I will not use this motor here. Okay, I will take another bit. Let's say this is the binary bit, soft bit, you can say. I think you also used during some project designing of your programs in the microprocessor. Okay, so here I will take that output. Okay, so the problem statement is what? Now my motor should start after 10 seconds of this bit 3 bit on. Okay, so what we'll do here, we'll take one input of this bit, and we will start the timer on delay timer. Okay, so this T4:0, I have to give the name of the timer. 10-second time. The time base is 1. Time base is 1, which means increment of 1. With the increment of 1, it will execute the time. And the preset time is 10. Means after 10 seconds, an accumulator value is 0. It remains to be 0 because it changes in online mode. Okay, and here I will take the another rung, and on this rung, let me just on the one you can see right now full screen. So on the second rung, I will take a bit here, this bit, and I will take another bit, that is T4:0 slash done. Done bit. Okay, what does done bit means? Let's say you have started the, let me verify this first. Let's say you have started the push button, means turn on the push button, it will start the this bit. This bit will become 1. Okay, this bit will become 1. If it is 1, it will start the timer. If the timer started, it will count the accumulator from 0 to 10 at an increment of 1. Okay, and as soon as it reaches equals to 10, means preset equals to accumulator. If this preset is equals to accumulator, then what happens? It will turn on this done bit, and this done bit, if this done bit becomes 1, then motor will get started. This is the problem statement, simple. So let me start the, let me download the program here. I'm downloading this. Okay, so I'm pressing the start push button, toggle and release. So you can see the timer count 4. Since motor is not started, as soon as it reaches to 10, motor is get started. Okay, and now if you press the stop push button, it will turn off automatically. Okay, let me press this release it. Press and release, both functions you have to do manually because I don't have any kind of push buttons with me. ठीक है, तर so here motor is stopped right now. Okay, now the same thing. Now if you go in a field and there are thousands of motors, so all the times can you do the same program check here? You cannot do the same thing. You require a graphical interface there. So for that, I'm just doing the graphics for the same thing. So let me do one new window here, graphics, the demo. Okay. So here, this is my graphics window. Now on this demo, I will try to indicate the button or switch or lamp. Yes, so this is better indication. So I will take this. Okay, so this is my lamp. Okay, so and I will write here just a minute. Okay, let it be. I'm trying to add one text here. Not getting that thing. So fine. So assume that this is my motor. Okay, motor is having one kind of lamp is on the motor, which shows that it is on or off. Okay, fine. So now I will tag this motor with my input address. This motor I have to show. I don't have to don't want to see you have multiple motors at a time. So you have to monitor all these things. So for that, I'm just tagging this motor. So for that, I am just double clicked on this. I will just give the expression of this. It's saying like it is open somewhere, but okay, let it be. It is not opening, but I think you got the point. Means all the time we cannot monitor these programs, correct? So we need to monitor the graphics, and it is very convenient because thousands of program, thousand lines of program. How can you monitor these things? Correct, no? So that is why you have to monitor the graphics which is having multiple input and outputs given on the monitor, and you can just check the status of this, and below that you can see the what is the tag name of that, and just you can relate this program or this application is related to that program. And then if you want to change any kind of program, you can go come here, or else you can double click on the same graphics and you will just pop up on the program which you have to change. Okay, so this is how you can just control your whole things properly. And SCADA is not able to open here. I have to check the problem, but right now it is not opening. Okay, so no issue. I will try to summarize all the things. And one thing I have forgot to tell, that is DCS. So I hope all you understood how the programming is done in the PLC. There are multiple programs, means like there is a add calculations, on off, then input output handling, analog input output handling, compare instructions. If it is equals to, it is very simple, similar to the microprocessor and microcontroller. Okay, so the way of showing is little bit different. Okay, so let me go and give you the last part of this webinar, that is DCS. So here you can see I will explain the Yokogawa DCS here. So you can see this is the control room where the operator is seated, and there is one only DCS here, and monitor screens are there. There are the cabinets where the CPUs and controllers are placed here. And there is only one engineering station and others are operators station. And let's say I'm starting from the real panel. This is the DCS which is I'm having here. And now this is the back panel, means rear panel. And here on the rear panel, just I have shown the architecture as well. This is there, the wires comes from the downside here, from here, downside the wires from the field comes, and they go through this cable trace to these modules. Okay, they go from this cable tray to the specific, like here or here. Okay, here. So they go here. Okay, in the back panel. And let's say after that you can see this is the power supply. So all the parts we will try to explain fast. This is the power supply which you can see on the DCS, which is used to convert the 230 to 24 volt, which is required for all the devices. Then there is the diode modules. So two diode modules for two power supply. Yeah, I think you understood what I am meant to say. And if the power of one supply is in working, then there is a diode after the both power supply, so that the power of one power supply cannot interface, means cannot um, goes to the another power supply. It will directly goes to the bus line. This is the bus line. Okay, and from this bus line we can get a 24 volt supply. And these are the analog input, analog outputs, digital input, digital output. These are the wires we have to connect it, and all these are the digital, analog, all these are connected. And from that only one cable is going to the back front side, means controller side. Okay, so you can see these are the analog transmitters just for simulations. So this is how the real panel look like. Now the front panel is look like this. Very basic things I'm showing, nowhere else you can see from the starting of the project. Okay, you can see everywhere, but you cannot see this from the starting how it happens. So this is a fan unit, means to cool the temperature inside the cabinet. Okay, and this is the main heart of the DCS, that is controller. So this is the controller. Let me some zoom this thing. So this one is the two controllers. Both are redundant. If one is fails to work, then other will take a action. Okay, the same thing, just like PLC, they also have a LEDs here. Okay, to show which is faulty, which is running. There is a battery as well here, which used for multiple hours. Means even if your backup is empty, then it will try to supply the processor. Okay, and these are the processors, power supplies, right one. Then there is a expansion slot for future further use, and these are the analog modules, analog input, analog output, DIDOs. And somewhere I have mentioned that um, field bus applications, means in advanced technology automation is done using field bus. So these are the field bus. Instead of junction boxes, we are using this foundation field bus for the controlling, because it is very helpful for diagnostic of devices. These are the communication units to control the processor, controller, and devices. Both can be communicated with using these cables, Ethernet cable, because these are the protocols used in this DCS. This is the backup connection for UPS. So I hope you all understood the how this DCS is look like, PLC architecture and SCADA and PLC programming. If okay, uh, so this is from my side, ma'am. If you have any kind of problems, want to ask questions from students or anyone, they can ask now in chat box, or they can unmute and ask whatever.
Yes, sir. Yes, sir. Thank you so much, sir. It's a very wonderful session. We have explained very practically and point to point. So now we will take some questions from the students. Students, if you are having any doubt, you can ask the question. Anyone? All of you? Anyone? Any students? Any doubt, please? Any questions regarding PLC and SCADA, DCS systems, automation? Okay, sir. Can you close the screen?
Even if faculty want to ask some question, they can. Sir, I have one question. Suppose in our college, if we want to start or develop the lab related to PLC system, what should be the basic or minimum requirement and how we can move further? Tushar, sir.
Yes, ma'am. So for lab requirement of PLC and DCS, at least one PLC is sufficient for students. That what I think means, or two PLC. Okay, so in two PLC you can take out batches of 4 to 5 students, because each PLC consists of like one PC and one application. So like if you have two PLC, then it is sufficient, and there is a application we have to purchase for that, which can be interface with the same PLC. And if students are developing or designing any further applications by their own, they can be also interface with the PLC. So you don't want to buy anymore else another for applications. Just
Okay,
like
that means suppose in the machine lab or any other lab, if we want to do it's automation or direct means SCADA system we want to develop. So can we do the same?
Yes, ma'am. You can do. Just by purchasing 2 PLCs are sufficient, I guess.
Okay. Now you have discussed so many PLC systems of Siemens and other companies as well. So as you have worked in this field, which will be better or which will be easy for operation of the student?
It is Rockwell PLC, Allen Bradley PLC.
Okay. Over to you. Dheeraj sir.
Yes, sir. Sir, one more question is there.
Hi, sir.
Sir, what is difference between the Arduino and microcontroller?
Microcontroller, sir, is a dedicated one. Means only certain work applications you can use for using microcontroller, and the limitations are there. But Arduino is like microprocessor. You can do the multiple application using Arduino, and you can also connect multiple interfacing devices like Wi-Fi router. Then you can also even extend the iOS using Arduino, or you can just do the projects of IoT. Various things you can do, sir, using Arduino. But if you do the microcontroller, it will give you certain limitations.
Okay. Thank you, sir. So, any doubts, please, students? Any questions?
If students are not asking any doubt, it means that you have cleared everything, or it is not at all you are gone through it.
Okay.
There are only two options. Either you understood everything or you haven't understood anything.
Okay, thank you.
I also want to share one thing that we have done a project blog, means we have did one blog here. So inside this blog, if you have any problem, then you can go and see this thing. So Smart Insto class is the blog name. Okay, so here you can go Smart Insto class. There is everything related to automation. This is only for students, which is in instrument SGS college. They refer this or some idea about instrumentation automations, or the whatever the seminars I have given here in the presentation format. All these things can be available here only. So it is all available for the students. If they don't, they want to see this, they can really go and check here. And else, we also have DCS video.
Tushar, can you give the link of the same in the chat box so that will help to everyone?
Yes, ma'am.
Again, if any 15 days etc workshop or STTP is there, either for student as well as for faculty members from your institute, please tell us so that the students who are interested in that, they can take the benefit of the same. Hello?
Yes, ma'am.
And if in the HGGS, if such 8 days, 15 days workshop is there, let us know that so that students can take the benefit of the same.
Okay, ma'am. I will let you know.
Okay.
So these are the two links which you can refer for the automation. So this is from my side, ma'am.
Okay, thank you very much, Tushar sir. So over to you, Viresh sir.
Yes, madam. I like to invite the Power madam to give the vote of thanks. Power madam.
Yes, sir.
Yes, madam.
First of all, good afternoon to all. I am Miss Madhuri Pawar, here to give vote of thanks. So first of all, I would like to propose hearty vote of thanks to our chief guest, Mr. Tushar Bhasakwan, for making excellent presentations and making this webinar interesting and meaningful. Also, thank you. Thank you for telling us various industrial challenges and need for industrial automation with innovative strategies and solutions. And each and every point explained and shown in detail. So our student will get familiar with PLC, SCADA and distributed control system. Thank you for giving this knowledgeable information. And next, I would like to express gratitude to our principal, Dr. BP Rongi sir, for giving us chance for this webinar, and our beloved HOD Madam, Dr. D.A. Tamboli, for her continuous support and guidance, and all the professors for their cooperation. So finally, the sincere students who have attended this webinar in such a great numbers and shown their interest in this webinar. Once again, I thank for your cooperation. Thank you all again. Okay.
Thank
Okay.
you, ma'am. Thank you, sir.
Thank you so much, sir. So we will be in touch with you. So with this, I would like to conclude, end the session. So this session is declared. You can leave the meeting now. Thank you, all of you.
Thank you, Tushar.
Thank you, ma'am. Yes.
Yes, thank you, sir. I will end the session.
Yes, sir.